All right, in this video, we're going to talk about section 5.8 with inverse trigonometric integrals. Let's go ahead and talk about the three different forms that we can have here. And we only have three formulas. We don't have cofunction forms of these. So we can have du over root a squared minus u squared is equal to arc sine of u over a plus c. So that's form number one. Then we have integral of du over a squared plus u squared, and that turns into 1 over a arc tangent of u over a plus c. Form 1, form 2, and form 3 is the more complicated one. This is du over u comes a square root of u squared minus a squared. That turns into 1 over a arc secant of, and I use the absolute value sign here, absolute value of u over a plus c. So those are my three forms. Write them down. We're going to be using those quite a bit here. And you'll need to be able to identify which of these integrals is at play. Is it a constant part minus a function of x squared part inside of a square root in the denominator? Is it a sum of squares in the denominator here, constant part that's the square of something plus the function of x squared, and the numerator is a constant multiple of the derivative of the square root of this part that's the function of x? Or is it a square root that's got function of x squared minus constant squared, and we have the square root of that function of x or a constant multiple of it on the outside that we can fix, and a derivative of this function all by itself here, or constant multiple of it up here in the numerator. So let's go ahead and let's look at some examples. As I work through them, I think you'll understand how this plays out, but there's only those three options. So square root 9 minus x squared dx. So I see that this is a squared minus u squared is 9 minus x squared. My a squared is 9, making a equal to 3. My u squared is x squared, making u equal to x, and du will be dx. So this is integral of du over a squared minus u squared, which I know is arc sine of u over a plus c. So that's going to be arc sine of u over a plus c. And I just make my back substitutions there for u and a. So arc sine of x over 3 plus c. Look now at number 5. Integral of 1 dx over x root 4x squared minus 1. So u squared minus a squared is 4x squared minus 1. U squared is 4x squared, making u equal to 2x, and du equal to 2 dx. A squared is equal to 1, a is equal to 1. So I need u on the outside, so this is going to be a 2 and a 2 multiplied by 2 over 2 here to fix this, and that makes this integral of 2 dx in the numerator and 2 x on the outside of my square root, and 2x quantity squared minus 1 squared here is integral of du over u root u squared minus a squared. And that gives me a 1 over a arc secant of the absolute value of u over a plus c. Well, a is 1, so 1 over 1 is 1. Arc secant of the absolute value of 2x over 1 is absolute value of 2x. I'm going to put parentheses around there just to be clear that that's inside the arcsecant function. And that is number 5. Let's look at number 7 now. Seven is integral of 1 dx root 1 minus quantity x plus 1 squared. So a squared minus u squared is equal to 1 minus x plus 1 quantity squared. A squared is equal to 1, a is equal to 1, u squared is quantity x plus 1 squared, u is x plus 1, du is dx, 1 dx. So this is going to be integral of du over root a squared minus u squared, which is equal to arc sine of u over a plus c. So that's going to be arc sine of x plus 1 over 1 is x plus 1 plus c. Let's look at number 9. 9 says the integral of t root 1 minus t to the 4th in the bottom. So a squared minus u squared is equal to 1 minus t to the 4th. A squared is equal to 1, making a equal to 1. U squared is equal to t to the 4th, making u equal to t squared. And du equal to 2t dt. So if I need a 2t dt in the top, then I need a 2 and I need a 1/2 to balance it out. So that makes this 1/2 integral of du over root a squared minus u squared. And that's going to be 1/2 arc sine of u over a plus c is 1/2 arc sine of t squared over 1 is t squared plus c. Continuing on now to number 15. Says the integral of negative cosecant x cotangent x over root 25 minus cosecant squared x dx. So I see that my a squared minus u squared is 25 minus cosecant squared x, making my a squared equal to 25 and my u squared equal to cosecant squared x. A is equal to 5, u is equal to cosecant x, and du is equal to a negative cosecant x cotangent x dx. So that makes this integral du over root a squared minus u squared, turning this into a arc sine of u over a plus c. So this is arc sine of u is cosecant x over a is 5 plus c. Let's go ahead now and look at 17. 17 says integral of 1 dx in the numerator, square root of x times the square root of 1 minus x. So a squared minus u squared is equal to 1 minus x. A squared is equal to 1, u squared is equal to x. A is equal to 1, u is equal to the square root of x. Du is equal to 1 over 2 times the square root of x dx. So I need a 2 down here and a 2 out here to balance it out, making this 2 integral of root 1 squared minus the square root of x squared times 1 over 2 root x dx is 2 integral of du over root a squared minus u squared is 2 arc sine of u over a plus c is equal to 2 arc sine of square root of x over 1 is just square root of x plus c. Let's look at number 19 now. Number 19 is integral of x minus 3 over x squared plus 1 dx. So I'd like to split this into two integrals. And this is a basic u substitution. So 2 and 1/2. And in this other one, this is my basic form of arctangent. So I have 1/2 ln of the absolute value of x squared plus 1 is just x squared plus 1 since it's always positive, minus 3. This is the basic form of arctangent. Let's see, let's define here that my u is x, my du is dx, my a squared is 1, my a is 1. So divided by 1, arctangent of x over 1 plus c is 1/2 ln of x squared plus 1 minus 3 arctangent of x plus c. So 21 will be similar but different. Integral of x plus 5 dx root 9 minus x minus 3 quantity squared. So a squared minus u squared is equal to 9 minus x minus 3 squared. A squared is 9, making a equal to 3. U squared is x minus 3 squared, making u equal to x minus 3. And du equal to dx. So let's split this into two pieces. X over root 9 minus x minus 3 squared plus 5 integral dx over root 9 minus x minus 3 quantity squared. So this is my new piece that is the arc sine rule here. This other piece if I would look at u is equal to 9 minus x minus 3 squared, du would be a negative 2 x minus 3 dx, but I really don't want to do that. I would rather, let's expand this. It's going to turn out the same way. But let's make this 9 minus x squared minus 6x plus 9 is going to make this equal to 9 minus x squared plus 6x minus 9 is going to be a negative x squared plus 6x. For my u, and my du will be a negative 2x plus 6 for a, so it'll take some fixing. I actually like the first method, and I'll show you why. I make this 9 minus 3 squared, du is a negative 2, x minus 3 dx. So first things first, let's go ahead and subtract 3, and let's add 3 to balance it out. So that's going to change this into integral of x minus 3 over root 9 minus x minus 3 squared dx plus 8 integral dx over root 9 minus x minus 3 quantity squared. And now I need to make a negative 2 constant multiplier and a negative 1/2 constant multiplier out front. So this is, let's write these forms, negative 1/2 integral of u to the negative 1/2 du plus, then this is going to be 8 arc sine, this is 8 over 3, because it's 1 over a, and a is 3, arc sine of u, which is x minus 3, over 3 plus c. So this is negative 1/2 u to the positive 1/2 times the reciprocal of 1/2 is 2 plus 8/3. I really shouldn't put this plus c on there yet. 8/3 arc sine of x minus 3 over 3 is negative square root of, and I already simplified this earlier, but I'll just write it this way because that's how they wrote it to start off with. Plus c, and the book is probably going to simplify that into, what did we get? 9 minus x squared minus 6x plus 9. 9 minus 9 is 0, plus 8/3 arc sine x minus 3 over 3 plus c, and then this is going to be negative root, I'll call this 6x minus x squared plus 8/3 of arc sine of x minus 3 over 3 plus capital C. And they like to write the negative part second as subtraction. Like so. All right. Now let's look at number 23. Moving on to definite intervals now. 23 is definite interval 0 to 1/6, 3 over root 1 minus 9x squared dx. My a squared minus u squared is 1 minus 9x squared. So a squared is equal to 1 and u squared is equal to 9x squared, making a equal to 1 and u equal to 3x and du equal to a 3 dx. That gives me a du over root a squared minus u squared. I'm going to go ahead and change my limits of integration with my definition of u, that u is equal to 3x. 3 times 0 is 0. 3 times 1/6 is 1/2. So now we have this is arc sine, so arc sine of u over a, where a is 1. I'll say 1 squared. This is going to be u over 1, and u gets evaluated from 0 to 1/2. It's going to be arc sine of 1/2 minus arc sine of 0. Arc sine of 1/2 is pi over 6 minus arc sine of 0 is 0. So that should give me pi over 6 for my answer. Let's look now at number 27. Says 1 to 7, 1, 9 plus x plus 2, 1d squared dx. So a squared plus u squared is 9 plus x plus 2, 1d squared, making a squared equal to 9 and a equal to 3, u squared equal to x plus 2 squared. U is x plus 2 and du is dx. So making my substitutions, u is x plus 2, so 1 plus 2 is 3, 7 plus 2 is 9, 1 over 3 squared plus u squared. Do I have a du? Yes, I do. So this is du. So this is going to be equal to 1 over a, which is 1/3 arc tangent of u over a, evaluated from 3 to 9, will be 1/3 arc tangent of 9 over 3 is 3, minus 1/3 arc tangent of 3 over 3 is 1. Well, I know that this is pi over 4, and this is 1/3 arc tangent of 3. So this is 1/3 of the quantity arc tangent of 3 minus pi over 4. And that is going to be y equals arc tangent, so second tangent of 3 minus pi over 4 divided by 3 is approximately 0.155. This is my exact answer that I have on the left-hand side, and I have an approximation on the right-hand side just to help you out. Let's look at number 31 now. 31 is integral pi over 2 to pi sine x over 1 plus cosine squared x dx. So a squared plus u squared is 1 plus cosine squared x. A squared is equal to 1, u squared is equal to cosine squared x. A is 1, u is cosine of x, du is a negative sine x, so I need to fix that here with a negative and a negative. So that's going to give me negative integral of, if I stick in pi over 2 to u here, cosine of pi over 2 is 0. Cosine of pi is negative 1. Then I have 1 squared plus u squared and a du up there. So this is going to be negative 1 over 1 is 1. Arc tangent of u over 1 is going to be u. Evaluated from 0 to negative 1. Well, I should change my bounds of integration before I do this. This is going to be negative 1 to 0 du over 1 squared plus u squared will give me 1 over 1 is 1. Arc tangent of u over 1 is u. Now that's evaluated from negative 1 to 0. So that is arc tangent of 0 minus arc tangent of negative 1. Arc tangent of 0 is 0. Arc tangent of negative 1 is a negative pi over 4. So that's going to evaluate to be pi over 4. Let's look now at number 33. 33 is integral from 0 to 1 over root 2. Arc sine of x over root 1 minus x squared dx. Going to write that as 0 to 1 over root 2. Arc sine of x times 1 over root 1 minus x squared dx. If my u is equal to arc sine x, my du will be 1 over root 1 minus x squared dx. So this is a simple u du substitution. Arc sine of 0 is 0. Arc sine of 1 over root 2 is pi over 4. So this is going to be 1/2 u squared, evaluated from 0 to pi over 4 is 1/2 of pi over 4 squared minus 0 squared is 1/2 of pi squared over 16 is pi squared over 32. This will be another one that I'll approximate for you. Pi squared over 32 is approximately 0.308. Moving on to 35. We many times have to complete the square to get this in the form that we want. More of that when we do some of this in other sections, but for right now, let's try to complete the square here with x squared minus 2x, have the plus 2 down here. Half of the middle number squared is plus 1, so I'm going to minus 1 to balance it out, and this is 0 to 2 of x minus 1 d squared plus 1 dx. So my a squared plus u squared is 1 plus x minus 1 d squared, with a squared equal to 1 and a equal to 1, and u squared equal to x minus 1 squared, u equal to x minus 1, and du equal to dx. U is x minus 1, 0 minus 1 is negative 1, 2 minus 1 is 1. This is du over a squared plus u squared, where a is 1, will be 1 over a is 1. Arc tangent of u over a is u. And then this is evaluated from negative 1 to 1. So arc tangent of 1 minus arc tangent of negative 1 will be pi over 4 minus a negative pi over 4. It's pi over 4 plus pi over 4 is pi over 2. Let's look at 41. Forty-one says 2 to 3 of 2x minus 3 over root 4x minus x squared dx. And let's see what happens if u is equal to 4x minus x squared to start off with. Du is 4 minus 2x dx. So let's start with 2 to 3, and let's make this 3 minus 2x, 4x minus x squared, and I'm so close here. If I do that, that's negative there. And so I need to add 1 and subtract 1. So this is my 4 minus 2x, so integral 2 to 3 of 4 minus 2x dx over 4x minus x squared to the 1/2, and then minus a negative 1 is plus 1. It's an integral of dx over root 4x minus x squared. And that's also from 2 to 3. So this is a negative integral 2 to 3 of, let's say here, u. We already did u up here. So negative, and then u is 8 minus 4 is 4. 12 minus 9 is 3. This is u to the negative 1/2 du. I'll leave this one alone for right now and work on it in just a minute. What I will do there is pull out this negative so I can start working on it. This one is going to be negative u to the 1/2 times 2. This is going to go from, let's fix this before I do that. This is going to go from 3 to 4, u to the negative 1/2 du, plus 2 to 3 on x. And then I want dx, and we need x squared minus 4x. So half of the middle number squared will be 4. Let me do this in a different color so you can see what I'm doing. Plus 4. And then that really was a negative 4 that I just added. So I'm going to put a 4 there to balance that. And that makes this u to the 1/2, 2 there. This goes from 3 to 4 plus, and now I have u, let me finish this up, 2 to 3 of, and then this is 2 squared minus x minus 2 squared dx. All right, so this is 2 times, and then 4 to the 1/2 is square root of 4 is 2, minus 3 to the 1/2, that's square root of 3, plus, now I'm going to make some substitutions here, where a is equal to 2, u is equal to x minus 2, and du is equal to dx. So this is 2 minus 2 is 0, 3 minus 2 is 1. This is going to be root 2 squared minus u squared. This is du. So this is 4 minus 2 root 3 plus, and then 1 over, this is arc sine of u over 2, and this is evaluated from 0 to 1. That is 4 minus 2 root 3 plus arc sine of 1/2 minus arc sine of 0. This is 4 minus 2 root 3 plus pi over 6 minus 0 is 4 minus 2 root 3 plus pi over 6 is approximately 4 minus 2 root 3 plus pi over 6, rounding that to 3 decimal points, 1.059. So now at number 43. Number 43 says integral root e to the t minus 3 dt. Use the specified substitution to find or evaluate the integral. They tell us to let u be equal to the square root of e to the t minus 3. That tells me that u squared is e to the t minus 3. And u squared plus 3 is equal to e to the t. T is equal to ln of u squared plus 3 dt du is equal to u squared plus 3 2u, so dt is 2u over u squared plus 3 du. So this is integral of u times 2u over u squared plus 3 du. So going to give me 2 integral u squared over u squared plus 3 du. I need to divide with long division since degree of the top and degree of the bottom are the same. So 1 u squared 3, change my signs and add, minus 3 over u squared plus 3. So this is 2 integral of du minus 2 times 3 is 6 integral of du over u squared plus 3. So this is going to be 2u minus 6, and a is equal to the square root of 3 here, and you already see this is u squared and this is du, so that's perfect. This is in the form of arctangent, so need 6 over root 3 arctangent of u over a plus c. So I see that 6 has a factor of 3, and I need to go ahead and rationalize here. 6 root 3 over 3 arctangent of u over root 3 plus c. 3 goes into 6 2 times. 2 times, now let's go back to my u. My u was root e to the t minus 3 minus 2 root 3 arctangent of root e to the t minus 3 over root 3 plus c. I would have no problem. This is the way that the book wrote it here. I would have no problem with you writing e to the t minus 3 minus 2 root 3 arctangent of, and then big square root e to the t minus 3 over 3 inside of the arctangent plus c, since square root of a over square root of b is equal to square root of a over b. I have no issue with that. The book liked it better with the square roots split top and bottom. So that's the way we'll write it. And let's see, I really don't need these parentheses around this. Just put this 2 directly in front of that. And that's good. Let's look now at 47. Gives us a few different problems and wants us to try to work on them. Here, 1 minus x squared dx. So this one is going to be in the form of root a squared minus u squared du, where a squared is 1 and a is 1, and u squared is x squared, and u is x, and du is dx. So this is 1 squared. So this will be 1 over 1 is, u over 1 is u, and I do arc sine. Arc sine of u over 1 is u plus c. This will be arc sine of x plus c for part A. For part B, we have integral of, and they put an x in the top here, 1 minus x squared dx. So I'm going to make u equal to 1 minus x squared. Du is going to be a negative 2x dx. Let's make this negative 2 and negative 1/2. This is negative 1/2 integral of u to the negative 1/2 du. So that will be negative 1/2 u to the positive 1/2 times the reciprocal of 1/2 is 2 plus c. So this will be a negative square root of 1 minus x squared plus c. For part C, integral of 1 over x root 1 minus x squared dx. That's not right. If it had been x squared minus 1, where it was u squared minus a squared with the u on the outside and the du up top, I would have been able to do it. But since this is a squared minus u squared, and I would have had a du up here without the x, I would have been able to do that. But this does not fit any of the forms, so we can't integrate this, and I'll say yet. We don't know how to integrate it yet. Meaning we can't integrate this with our basic integration rules. So we'll need more advanced techniques. That gives you a look ahead to there's other types of problems that we might be able to do later with more advanced techniques. This could be one of them. We'll see. Maybe we'll come back to that problem later in Calculus 2. For right now, let's move on to problem number 63. '63 asked me to find the area under the curve for the function that has 2 over root 4 minus x squared in the denominator dx, where x is going from 0 to 1. And so this is in the form of a squared minus u squared is 4 minus x squared. So a squared is 4. U squared is x squared, a is 2, u is x, du is dx. So 2 integral 0 to 1 of 2 squared minus u squared du. I need to change my limits here so that they are, oh, I don't need to change my limits because u is equal to x. Awesome. So this is arc sine. So I have 2 arc sine of u over a, u over 2, evaluated from 0 to 1. This is 2 arc sine of 1/2 minus 2 arc sine of 0 is 2 times pi over 6 minus 2 times 0 is pi over 3 minus 0 is pi over 3. 71 is a true or false question. And it asks if the integral of this is true or false. The integral of dx over 3x root 9x squared minus 16. Is that equal to 1/4 of arc secant of 3x over 4 plus c? Well, let's see what this is actually equal to. Maybe it equals what's on the right, maybe it doesn't. So 3x root 9x squared minus 16. So I see a u squared minus a squared situation. That's 9x squared minus 16. U squared is 9x squared, making u equal to 3x, and du equal to 3dx. That makes a squared equal to 16 and a equal to 4. Says, let's see, I need a 3 dx in the numerator. Gives me a 1/3 on the outside. So 1/3. This is u. And this is root u squared minus 4 squared. And this is du. So that will be 1/3 times 1/4 arc secant of u over 4 plus c will be 1/12 of arc secant. U is 3x. Sorry, this is absolute value here. Absolute value of 3x over 4 plus c. So it's not quite right, because the things that are missing are that I should have had a times 1/3 out here because of this needing to get a 3 dx in the top, and I should have had absolute value bars around my 3x because it needs to be forced to be positive there. So the answer is that this statement here is false, and the correct answer is down here. And that's it for this video. And we will come back next time and talk about section 7.2. See you for the next video.